Good evening. Yet another Angular talk. I'm going to talk about security in Angular. Before we start, I have a question for you to think about. Just give it a few seconds. What do you think is the biggest threat to an AngularJS application? Think about it. If you develop an application, it's the biggest threat. Maybe you have something in mind. Well, for me, it's actually developers. And I don't mean that in a bad way. I mean it that developers that don't know about security, that are not aware about security, they're bound to make mistakes, and I will show you that even in Angular you can make mistakes that will be devastating to your application. And the reason I'm telling you this is not to offend you. I see people leaving. I hope it's not because of what I said here. The reason I'm saying this is not to offend you, it's to say that I'm a trainer in web security. So my job is to train people in web security. I build applications for myself, I build small-time things, but I'm not a developer of applications that are used from day to day by thousands or millions of people. That's what you do, probably. That's why I'm here. So I'm here to talk about how to build secure applications. That's what I'm going to do in this talk as well. I organize training courses as well. I give talks at various conferences, things like that. I work at the university. I did my PhD in web security. So essentially I'm an expert in web security. I wrote a book on web security as well during my PhD. And since I got my PhD, I've been doing trainings. So I'm running a training program from the university. It's an important part of what we do. Essentially that we want to transfer the knowledge that we have about security to practitioners in the field. I'm also a chef, so I have some demos that will be food related. So anytime you see this guy popping up, that means that there's a demo coming, and I want to show you a few things about security in this case, not about food. It will make you hungry probably. I have some pictures as well, so that's for something after this talk. You can grab some food. In this talk I want to talk about cross-site scripting. Cross-site scripting is a vulnerability we have in web applications, a vulnerability we have in a lot of web applications, and that's actually quite dangerous. Very brief introduction. Cross-site scripting actually happens when malicious content is injected into your applications page. So I have a very stupid example of what cross-site scripting can be. Let's say you have a search box somewhere and somebody enters a script tag, and this happens, then you're in trouble. The reason you're in trouble is because, not because of the alert, but because of what it enables. It enables a hell of a lot more. Cross-site scripting used to be scripts. It used to be the injection of a script tag which did some JavaScript functionality. Since a few years, cross-site scripting covers a lot more. It covers HTML injection, it covers CSS injection, you can inject SVG, you can inject a lot of crazy stuff that does a lot of things wrong in your application. And all of these things are considered to be the same attack vector with severe consequences. I'm going to show you what these consequences can be. Another example I have here, let me give you the sound, is essentially a video of what a cross-site scripting attack can do. And it plays the Harlem Shake from about 2 years ago. And these are websites from Dutch banks in the Netherlands, that were all vulnerable to these kinds of attacks. And what they actually did is to show that these banks are vulnerable to these attacks. And of course this looks funny, this raises awareness, and people are like, okay, that's a funny video, everything is dancing around. But essentially this means that whoever did this could have gotten full control of the page. This means that if you authenticate on this website, because the home bank runs on the same origin, the same domain, the attacker could have been in that page and could have been seeing what you are doing, could have been monitoring it, could have diverted you. And that's essentially why cross-site scripting is so dangerous. And the real problem is that the injected code, injected content runs in your context. And that means if you're an application that has access to the webcam, the injected code has access to the webcam. If you have a lot of data stored locally in the browser, the code, the injected code, the attacker's code has access to the data. And that makes cross-site scripting so important and so dangerous. It's so dangerous that it's in every top whatever of programming errors or mistakes. You have the OWASP top 10, that's purely web application vulnerabilities. They rank them, cross-site scripting is listed third. I think it's preceded by server-side injection attacks, which are maybe even worse, and broken authentication and session management. Same thing for the SANS top 25, that's not only web security, that's all kinds of programming errors. There it's listed fourth. So cross-site scripting is something to take seriously. And I have a final example to make you realize how important this is. And that's the browser exploitation framework, or BEEF in short. This is something I use in my training. So I have a training course where we cover XSS in detail and we have hands-on labs. And that hands-on lab is the eye-opener for people, and they actually use this tool. What you do is you inject one simple script into a web page, and the script calls back to this framework, which is running somewhere on a server. And from then on, you have a hooked browser, and the hooked browser appears here on the screen. And from then on, you can send any command you want to this browser. So you have a full list of exploits that you can use, pre-made, simply point and click. For example, you want to play a sound, click this and you play it. You upload a file, MP3 file, and you play it. You want to capture images from the webcam, which is what they did here. You can essentially see this is a picture, this is a data URL. You can render that into a picture. And this framework shows you the true power of cross-site scripting. You have commands to show a pop-up dialog asking you to install a Flash player. It looks just like the real thing. The only difference is, in this case, the attacker has provided the .exe file instead of Adobe. Really, really, really powerful stuff. Look it up. Look at videos online. This truly shows the power of cross-site scripting. So, this is a security talk. I'm not going to spend more time about scaring the shit out of you. I'm going to talk about how to protect against cross-site scripting. The root cause behind a cross-site scripting attack is essentially a confusion between data and code. And this is something we see in other places as well. Think about SQL injection, where you inject something in a SQL query. Why is this a problem? Because the server, in this case a SQL server, will be confused about which part of the string is query, SQL code, and which part is data that it should not be considered code. Same thing here. And why this is such a big problem? Because the server builds a page. The server has something like this. The server has some HTML code and he inserts some variables here. Doesn't matter which language it is, this is kind of universal. At that point, the server has a perfect view on the page. He knows this is code, which is essentially the HTML stuff and the JavaScript stuff, and this, the blue parts here, are data. We should consider them to be separate. And then he bundles this whole thing, he builds this page, and he bundles the whole thing, and he sends this to the browser. And this comes back to the browser, and at that moment the browser has to identify which is data and which is code. And he has no idea. He has no idea whether there's a script tag here, whether that's data or code. How could he know? You might think that it doesn't make sense to put script tags in titles, for example, but it's still, everybody does it. Everybody does crazy things. So yes, this will happen, and the browser has no clue anymore, resulting in a cross-site scripting attack. The only thing you can do against this, and I promise I'm going to the Angular stuff in one slide or two slides. So the thing you should do against this is escape the dangerous parts in the data. So essentially, on a meta level, it looks like this. The server should encode this data so that even though there might be some dangerous things in there, they will be escaped. So in this case, this would mean that instead of a script tag, it's replaced with the ampersand LT, which the browser doesn't interpret as a script tag anymore. The browser knows, okay, this is some data, let me render it, and it will render the script tag on the screen. This seems simple enough. The problem is, in real life, in the web, you need to do this for every different context where the data appears. So you can have script tags in HTML elements, that's fine. But you can also have something in HTML attributes, an on-click handler, for example, an on-blur. That's something that executes JavaScript. You have style sheet stuff where you have untrusted data. You have script context. So you need to do this for every context and you need to do it right. If you're building a traditional web application, which for example Csp pages, there are libraries that do this for you. So you don't have to do this yourself. Please don't try to do it yourself. Use a library. So what's the deal with Angular? That's from now on, I promise I will only talk about Angular anymore. So what do we do there? There are essentially two scenarios we need to cover. The first one is when you use Angular in combination with a traditional application. So what you see a lot is people having an old application, like an old traditional web application with server-side pages, like a Csp application. And they want to improve the UI, and they think, oh, Angular is pretty cool, let's use Angular. That will make our life a lot easier. In that scenario, you build this HTML page on the server with the potential confusion we had before, and then you include some partial AngularJS templates. Might look something like this. So you have a page, you have some Angular libraries there, and you still have the stuff we had before. But you're aware of cross-site scripting, so the server protects against these kinds of attacks, which is good. And then the question is, what happens if somebody enters this? Well, you might guess where I'm going with this. And the problem is, in Angular, a lot of new stuff suddenly results into code execution. For example, you have a div element, and the server does this cross-site scripting protection. There's text inside a div that will never trigger scripts in a traditional web application. If you have a GSP page, this will simply be a string. It will not be JavaScript. Unless you have Angular running on the page, and then that string of data suddenly becomes executable code. So to make it short, there are numerous other ways to do this. So in one word, no, you cannot no longer do this. This is something you will never be able to protect against, because the server has no clue what Angular will treat as code or as data. There was a German guy that spent a lot of time breaking Angular in that way. Mario Heinrich, maybe you've heard of him. Based on his work, the Angular team actually decided to implement an expression sandbox. So they decided to prevent access to these window functions, like alert and whatever JavaScript offers for functionality. This was implemented in Angular 1.2. The German guy kept breaking the sandbox over and over and over again, so they couldn't get it airtight, they couldn't fix it. So essentially, about a month ago, they decided to just stop doing that. They removed the sandbox again in 1.6. So this remains a problem, and this is a problem that cannot be addressed by Angular. So essentially, which brings me to the first conclusion of my presentation. I'm not done, I have 3 conclusions by the way, so don't hope just yet. And the first conclusion is, you shouldn't combine these templates on the server side with user-supplied data if you're using Angular. So essentially, if you want to use Angular with these kinds of pages, you should get the data separately. And I'm going to show you why that's the solution. So even, I have a small note on Angular 2, even with Angular 2, there's no solution for this problem. The security guide for Angular 2 says, don't do it. You can compile your template separately if you want to, but don't combine traditional server-side composed pages with Angular, because you will never get it secure. It's just not the way it works. So, important lesson. By the way, if you have any questions about these things, just raise your hand. We can go into detail during the talk, or you can ask them afterwards, or even after the talk when I'm still here. So, that brings me to the second part. What about the Angular way? The Angular way where we have an application, we have the front end, and we have a back end, we have an API. Well, think back about this confusion between data and code. This existed because the server created a page, gave it to the browser. With Angular, the server gives you static pages. Angular boots in the browser, and from then on, Angular knows what is data and what is code, because Angular will insert the data into the pages. This is how the template system works. So in a sense, this would mean that Angular would be able to protect you against cross-site scripting. And here's the chef guy, so let's take a look at how that would work. I've made this, nope, that's not right. Yeah, so I've made this very simple recipe application that doesn't do anything. There's no backend, it's only in the browser, but it allows me to show you a few of these concepts. So let's say you have a recipe. Looks pretty simple, it's all Angular in the background. What would happen if we would add this ingredient to trigger an alert, for example?
Philippe?
Yeah?
Can you zoom in a little, please?
Yes. Is that better?
Yes.
So we're adding this script tag here, which hopefully wouldn't trigger cross-site scripting attack. So if you save that, and you go here, what you see is, you see this script tag appearing in your HTML, which means that the browser didn't pick it up. The browser didn't process it as a script tag. It doesn't trigger an alert. And essentially, this is considered to be data, which is essentially what it is. It is data. If we go back here, I have good news for you, and that's essentially Angular knows which parts are untrusted. It knows that this is input that came from somewhere, that shouldn't be put directly into the DOM, and shouldn't be trusted. And this principle is called Strict Contextual Escaping, or SCE. That's part of Angular. Angular does this for you automatically. SCE, or Strict Contextual Escaping, is essentially the countermeasure I talked about before, which is why I gave this in the introduction. This is based on the context, Angular will look at where is this data being used. Okay, it's in an HTML element, so I'm going to make sure that there are no script tags in there. That's it. Do you use it in an attribute? Okay, I'm going to make sure that there's nothing that can trigger JavaScript execution in that attribute. And that's great. And this applies to all bindings you do with ngbind or the double stashes. And this is on by default since quite a long time. This is really, really awesome. This means if you build an Angular application and you do it like this, no cross-site scripting, at least not in that way. Of course, it brings us to another scenario. What if you actually want some HTML? And again, I can show you in a demo. This somewhere. So let's go back. If you have in my recipes here, you can customize the header. So as a user, you can specify some HTML there, which happens. For example, on some sites you can actually do this. All of these things are, by the way, based on scenarios I had in my trainings. People are like, yeah, but our application wants to allow this and that. Can I do it in a safe way? This is just a mock-up of such scenarios. So here you can edit this, and it's shown here, but it's still the ngbind here. So let's modify this a bit. This is the customized header here. So Angular also has this ngbind HTML. Can you read that? That big enough? ngbind HTML essentially allows you to bind data that includes HTML, which tells the SCE thing, don't escape HTML tags here because I definitely want some HTML in my output. So if you reload this page, no, it was, where's my page? My menu is broken. Okay, there we go. Reload this page, you get this. Okay, I'm not sure how I can, okay, just like that. Awesome. This is an error in the console, and you might think that we broke something, and actually Angular broke something for us. So essentially what this says is, you're trying to use an unsafe value in a safe context, which is, I don't know what, but my application is broken. That's not what I wanted to do. So, what's going on here? It brings me to the next point. So we want some HTML. Apparently Angular doesn't want to cooperate, so the first thing you start doing is Google this error. And you find Stack Overflow advice, of course. And on Stack Overflow you find something like this. Okay. And what they say here is, yeah, this is part of the solution. You need to create a filter, blah, 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 and essentially this is the solution. ngbind HTML, you have your data that needs to be sanitized. You push it through the sanitized filter and everything should be fine. Right? Okay, let's see. I have already copied that code into this sanitize filter. So that's essentially the code from before.
We don't see the code. You're not showing the...
Oh, stupid PowerPoint again. Thanks. Yep. There we go. This is the sanitize filter from Stack Overflow. And we apply this to our ngbind HTML. So we push this through the sanitize filter. And we should be happy campers. And we are, because now the HTML is actually being parsed. So we had this bold tag, the cooking is in bold, so we are happy, everybody is happy, and we can continue with the rest of our work. So at this point your tests will succeed. Sam is happy as well. Yeah.
The fun part here for me is that other people are really like acknowledging their like gorgeous, fantastic, thank you.
Yeah, but it works. Yeah. It is fantastic, it works. Until you get a call someday. Mm-hmm. And then some bad stuff happens. So this is something you couldn't see. If you just use the Stack Overflow solution, you don't see what's going on here. And essentially, you have opened your whole application to cross-site scripting attacks. So let's dig into this just for a minute. This is what they propose. They propose to use this SCE, which is the Strict Contextual Escaping in Angular, and you call this trust as HTML. If you would have taken one of the other links in Google, you would have found the Angular documentation, which essentially deals with this error. What they say here is, blah, 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 I'm protecting you against cross-site scripting. And the final line here is the clue. If you want to do sanitizing, you should include the ng sanitize module, which is an actual sanitizer. And if you go look at what this trust as HTML does, if you read the documentation, essentially what this means is you tell to Angular, I trust this string to be valid HTML, which is secure. I'm telling you not to consider this to be unsafe. I'm telling you not to sanitize it. I'm telling you to include it just as it is, because I as a developer vouch for its security. That's essentially not how the Stack Overflow post framed this, and that's not how they used it, but that's essentially what that does. So you shouldn't ever use this, and you should use ng sanitize. Again, demo time. Let me show you how to use ng sanitize. So let's disable this really crappy advice. Now we're back to the error, and to enable ng sanitize, all you need to do is, no, that's not here. You can simply, you have to install it, of course, which I already did. You enable it in your application. That's what you need. And then we go back here, reload the page, and we see that this still works. I can assure you that it will not be vulnerable to cross-site scripting. I could have shown it before, I didn't actually, but let me just show you what happens if we add some more script here. So this is definitely something that would have been possible with the sanitize filter if you do it here. And we go up here. The cooking is still here and nothing else happened. And if you would take a look at the source here, you would see that the script tag is completely missing. It's not in there. No script tag. And the reason it's gone is because this ng sanitize looked at the data, and ng sanitize, it's made by Angular, it's part of Angular, and the team has decided which things are safe to allow in the output and which things are considered dangerous. And a script tag is definitely dangerous. It will remove on-error handlers. If you include an image tag of a non-existing source with an on-error do something in JavaScript, that will work in a cross-site scripting scenario. It will be removed by the sanitizer. The image will still be there, the source will be there, the on-error handler will be removed. And you have this huge list of dangerous features in the web, essentially, which will be removed by sanitization, and everything else is allowed to remain in the output. And that's really, really awesome. Again, one of the great security features that are available, as long as you don't screw it up by doing something like trust as HTML. Is it clear? Yeah.
I have a question. Do they use like a whitelist approach or a blacklist? Do they remove things that are not allowed, or do they only accept certain things? So.
That's actually a good question. I don't know. I would have to look it up. I don't know by heart. I would imagine on the web that they would use a whitelist. Otherwise, things get messy really quickly. Especially with HTML5, a lot of new attributes have been introduced. So if they do it again, in a future version, that would mean that your filter becomes vulnerable, which is not something you'd want.
It's a limited list, so why not whitelist?
Yeah, I'm pretty sure it's the Google security team. They actually know pretty well what they're doing, so it should be a whitelist. I'm pretty sure that it is. Yeah. They'd have to verify, but I would put my money on a whitelist. So, Angular 1, let it do the work for you. So essentially what we covered here, a quick recap. If you have this simple context with the ng bind or double stashes, SCE will do it for you. So if you do it like this, this script will literally be in the output and you are protected, which is great. If you use untrusted data directly with ng bind HTML, Angular will simply say no way. It will not allow you to do something like that. Sanitizing allows you to do it because the sanitizer will remove the dangerous stuff. If you use this in this variable here, it will not be present in the output, so that's essentially a good way to do it. And this should only be used if absolutely necessary. And one of the cases why it's there is if you want to do something like this. If you want to specify a very small piece of HTML, a snippet in your code itself, and you want to output that in your template, you can do it by marking it as safe, but that's the use case for this trustless HTML, and that's the only use case. Not by marking untrusted input as safe, just something you wrote yourself. That's allowed here. And that allows me to talk about the Angular 2 stuff. In Angular 2, it's even better. The part of the confusion part of the cause of messing it up in Angular 1 is gone, because Angular does sanitization by default, Angular 2. So if you have this input with a variable and you output it like that, it will apply sanitization by default. No more errors, no more things that break, simply removes the dangerous ones. Second improvement, you can still do the dangerous behavior as before, but they have made quite clear that this is dangerous behavior because they have called it bypass security trustless HTML. If you write it like that, it's kind of a hint that you're bypassing security somehow, and you shouldn't be doing it like that. And then, for the record, the Stack Overflow post, I've been using it for quite some time to illustrate my story. This August, 2 months ago, somebody actually edited it and improved the answer. So you can see a lot of reactions here, like great, great, great. This guy was in one of my presentations last year, so he actually put a comment there like, no, no, this is not okay. And now, apparently 2 months ago, somebody actually changed this to trust instead of sanitize and edited that answer just for clarity. So I will have to find a new example for my future presentations, apparently. Which brings me to rule number 2. Do not mark untrusted data as safe. I think that's quite obvious. You shouldn't be doing that. You might think that it's something that will never happen to you, but actually I had people in my training which I told them about this, and a month later I saw them again at an event, and they were like, yeah, you know what, we had a new junior developer and he was writing some Angular code, and he actually used exactly that trick to mark something as safe and just output it in the code. So it's a good thing that you knew about it, because we got it immediately, and let's say we won't do it again next time. So yes, this happens in practice more than you might think, so don't do it, and use ng-sanitize for that. Any questions? All right, I said I had 3 things, so on to the third. There's a hard truth I need to tell you. You will have an XSS vulnerability eventually. That's just the way the web works, at least for now. It will happen, and it happens to the best. Google has them, Facebook has them, Twitter has them, everybody has them. If you're looking for XSS, you can make a lot of money, because almost all bug bounties give you a lot of money if you find a cross-site scripting vulnerability in one of the big sites. The reason it will happen is, what if there's a bug in Angular? That can happen. Maybe it's only there for a small window, but at least there will be a bug allowing someone to exploit XSS on your application. There's little you can do against that, except for one thing which has been available since about a year or 2 or 3, and that's content security policy. And content security policy is a new security policy, a browser security mechanism that you can use to lock down your client-side context. So essentially, it is intended to be a second line of defense against these kinds of attacks. So what you can do with content security policy is you can, first of all, you can whitelist the stuff you want to load in your page. So you can say, I only want to load scripts from my own website and from this CDN, nowhere else. So if somebody injects something that comes from I don't know where, just don't load it. Great. You can disable, or it disables inline scripts by default. So if you have the script block somewhere in the header, for example, script alert 1, the browser will not execute it anymore. It will only load external JavaScript files. And that's the real power of CSP. It disables this dangerous behavior and allows you to specify where stuff can come from, and based on that, you can have actually quite good security. And the whole thing is, the whole point of CSP is, if you deploy this, if you have a strict policy and something bad happens, then the attacker will be constrained. The attacker will not be able to do that much, and it's very likely that he will not be able to exploit this XSS vulnerability. You can imagine if CSP does all of this, for example, the refuse to execute inline script and style, you can imagine most websites have a lot of inline script and style. So one of the drawbacks of CSP is that it's unbelievably incompatible with most web applications, except for AngularJS and Ember.js and React.js and whatever. Why? Because you have a very clean way of building these applications. So the incompatibility comes from the fact that everybody mingles JavaScript and CSS and HTML all together. With Angular, you have a clean separation. You have your templates, which are HTML. You have your JavaScript, which are JavaScript files. and whether you compile it or not, it's still considered separate, and this enables you to deploy CSP fairly easily. Has anybody tried out CSP before? Yeah. How painful was it? Me? CSP. Did I say JSP? Okay, my apologies. Content security policy. Has anybody tried it? Yeah?
Yeah, me, but I mean, it was really, I had to make like Ajax calls between two different domains, and on SSL it wouldn't accept the answer from the other domain, so I just had to like do something on the other side. But I mean,
yeah.
I'm more like a mobile developer, so I don't.
It's more like a course issue, right?
A what?
Course issue, cross-origin.
Yeah.
That's something completely different, I think.
Yeah, maybe I'm talking about different things. Okay, yeah, sorry.
Yeah, okay, it's fine. Let me show you why CSP can be painful. Oh, let me exit the slideshow first. So, normally you would configure CSP on your server as a response header. You can also do it with a meta tag, and since I don't have a server, I prefer the meta tag in this case. So, let me show you what happens if you enable CSP. By the way, this policy here, this is a policy. It says by default, so for all resources that I don't specify specifically, it can only come from my own website. Nothing from outside, nothing else. So let's see what happens. If you apply that here, shit just breaks really bad. You can see we have no images anymore. We have a bit of style, which comes from our own website, which is good. And even the menu and everything is broken. And you have a lot of errors in the console. This is one of the reasons that people try CSP and then often run away and never touch CSP again. And that's why I want to cover it here, because it doesn't need to be like that. You can see here, all of these are CSP errors. So essentially, image wasn't loaded, it's a data URI, and the data URI wasn't whitelisted. So Chrome says, no way, I'm not doing it. Which is good, because if an attacker would have injected an image, it would not have been loaded. If an attacker would have injected scripts, which are here at the beginning, it would not have been loaded. So let's say the attacker injected something from code.jquery.com, it would be blocked by the browser. So let me show you very briefly how you can, what you need to do to enable this. Essentially, all you need to do is go through your list of errors here and whitelist these things. You're loading jQuery, you probably intended to load jQuery, that's fine. Simply add it to the policy and enable it. So I have already done that. It literally took me 2 minutes. Let me walk you through it. This is a CSP policy. First, let me show you what it does. That essentially enables this application to work again. See, everything looks like before. Getting hungry already? Yes? Let me walk you through it. What did we do here? So we kept this default SRC self, which means by default, if I don't specify something specific like these things, it can come from my website and my website. And then for scripts, we specify a more specific policy. We say scripts can come either from us, or we load this very specific file from jQuery, or this very specific file from Bootstrap. That's it. For images, you want to allow data URIs, because I use data URIs here. For styles, the same story. Ourself or something from Bootstrap, and some fonts from Bootstrap as well. Essentially, this is something you need to do once to get it compatible with your application. Once you've done this, it's very unlikely that this needs to change again. If I keep developing this application, unless I include additional files from CDN, I don't need to touch a CSP policy again. This is really, really awesome. This means if an attacker, well, I can actually show you. Let's do something stupid, like this, and disable and desanitize. And let's disable CSP as well. See, this is the script I injected to show you how ngSanitize works. We disabled ngSanitize and enabled the stupid sanitize filter from Stack Overflow, and we already have problems. If I would enable CSP, the problem doesn't occur, and Chrome actually says that it got some script refuse to execute inline script because it violates blah blah blah. So essentially, Chrome got this script that was trying to be executed and simply refused to do so because it violated the Csp policy. You can see, that's maybe the final thing about Csp I want to show you. You see that we still get one Csp error even though that everything still works. This is not an injected script, this is actually Angular causing some problems. Why? Because by default Angular uses inline scripts. Angular uses non-CSP compliant features, but it detects when CSP is present. So it tries to do something, things get refused. So Angular knows at that point, whoa, maybe I'm in a CSP enabled environment. Let me try CSP mode. And CSP mode works because Angular is actually initializing here. You can explicitly tell Angular to become CSP compliant by simply adding the ng-CSP directive here. So if you do it like that, the error disappears because Angular knows from the start I'm in a CSP environment, I shouldn't do nasty inline stuff with JavaScript, so let me simply avoid using that and become CSP compliant. And this is a very, very quick introduction to CSP. There's a lot more behind it. I can talk about CSP for 2 more hours if you want to. But it's really, really powerful, especially if you are in an Angular application where you don't have to deal with inline scripts, inline styles. It's all nicely encoded in your application, in your components, and it allows you to enable CSP. Very quick rundown of what you can do. So you have all of these resource types. You have scripts, images, styles, videos, objects, whatever. If you don't use them, simply set it to none. None is a keyword that says, I don't want it at all. If you don't use videos in your application, say, I think it's media SRC, none. Boom, no videos. Nobody can inject a video, nobody can inject a flash file and then exploit the vulnerability in that flash file. No, simply nothing. And if you don't specify something specific, default SRC applies always. So a few keywords, you have none and self. You also have a star, which is not recommended unless it's for images. It might be acceptable, but definitely not for scripts or something like that. Then you can have these host expressions. You can have various levels of host expressions. You can have only a scheme. You can have a host, a specific file. There are some guidelines there. I'll talk about that in 2 seconds. Then there are 2 features, unsafe inline and unsafe eval, where you can re-enable inline scripts if you want to. This is not something that's recommended. This is something that's there for compatibility reasons. If you need to do it, you can do it. For scripts, definitely not recommended. For styles, it may be necessary. For example, some libraries use inline style. There's no way around it, so you can re-enable that if you really need that.
I have a question.
Yes?
So CSP is an Angular directive, right? Or is it like a web thing? Because you say Chrome understands it. I don't understand how Chrome gets it.
CSP, Content Security Policy, is a security mechanism that is implemented in browsers.
Okay, so it's a web thing.
Yes, it's a web thing. It's supported by all browsers, at least level 1. The Angular thing is very specific. Is by default Angular is not compatible with CSP. By default Angular does some inline scripts stuff under the hood. And the ng-CSP directive simply tells Angular, I'm going to run you in a constrained environment where you shouldn't do those things. So I'm telling you up front, use your compatibility mode with CSP to not do these things. That's essentially all the ng-CSP thing does.
And if I was to actually apply those CSP rules in a old-fashioned web app with stupid HTML thing, I can do that.
Yeah.
Like in the meta part, or?
Yeah, or even with a header. For example, if you will, let me quickly show you. If you go to my website, this is built with Jekyll. So it's
still don't see it.
Oh, my apologies.
No problem.
This is just built with Jekyll templates, so there's no Angular in there or nothing. If you look at the network requests, you will see the CSP actually coming in. So this is the first request. There's a response header. That's essentially the content security policy. So this is delivered by header.
Oh, I see. Okay.
This tells the browser, this tells Chrome, like, you need to enforce this policy. You can, this is per page. Well, you can have a policy per page. This is just configured in Nginx for the whole site. You can have a per page policy. So you can say for this page, I want to apply this policy. For that page, I want to apply that policy. That's essentially how it works. And you can see, I include a lot more than in the example. That's to enable Twitter timelines and stuff like that. But all in all, once you've built this, you're good to go. Maybe one feature, since we're talking about it, CSP has a possibility to send reports. So when a violation occurs in a browser of a user, you can instruct that browser to send you a report of that violation. So you can follow up when something breaks or when an attack is happening or something like that. I don't have time to go into that in detail, but if you go to my website, I will refer to it a bit. I've just written a blog post about reporting and how you can leverage that to your advantage. So, CSP Level 1 has been available for quite some time. That's all you need for Angular, essentially, and it's supported in all browsers. Future versions of CSP, you have a Level 2 available now. Browser support is a bit less. Main changes that they did is they improved compatibility for older applications. So they allowed you to have some inline blocks and approve them as well. Csp Level 3, which is definitely not something I can cover here, is brand new. They're still working on it, and it's only supported by Chrome, some features. Mainly deals with including external components like a Twitter timeline. Because you can imagine you have to whitelist a Twitter timeline, and then that script includes other scripts and other scripts and other scripts, and that can become messy. In that case, they have a new directive which simply tells you if this script includes other scripts, I trust it, just approve it, and that's it. That's something I will probably talk about on NGBE, the Angular conference in December, because there I'm going to talk about Angular 2, which is more secure by default, so I have more time to go into CSP, for example. So, a few words on CSP policies. Like I showed you, you should actually deploy this with a header. That's the preferred option. You can use a meta tag if you don't have control over the headers, for example, or if you have an application running on a mobile phone or in the browser like I showed you here. Should make it as secure as possible. There are a few guidelines. There's more information on the link here. Shouldn't use unsafe inline and unsafe eval, we covered that. You should also be very specific about which files you want to include. If you simply whitelist the entire Google CDN, for example, then somebody can include vulnerable libraries from that CDN. And one of these attacks is actually including a very old Angular, like 1.0 or something, and then start executing attacks against that library. So if you have whitelisted that, your CSP will be bypassable. And then another potential attack is if you don't specify everything in your initial policy, then somebody might override your original policy with meta tags. Again, too complex to go into here. Simply try to be as complete and as strict as possible. Two tools that can be very useful to make your life easier if you want to give CSP a chance or another chance. Google Csp Evaluator, something brand new, built by Google to identify vulnerabilities and bypass attacks and policies. So you can simply run your policy through that. And reporturi.io is a service that you can use to collect your reports, your CSP reports. That's one thing. And they also have a tool to generate a policy. So you can simply say, I want to load images from here and this from there, and hit the generate button, and it gives you this string that you should post in your web server config form. Brings me to rule number 3. CSP is really, really powerful. It can be really messy in old applications, but it's very likely that your Angular application is super compatible with CSP. So give it a chance. Take a look at what it does, and actually try to deploy this for your application. It's definitely worth the effort. And I want to talk about a few other things. I mainly talked about purely AngularJS things, because my talk was about Angular, and I only had 30 minutes, but there's a lot more involved building a secure application. In the last 5 years, we have seen in the introduction of about 7, 8 new security technologies, including CSP, CORS, strict transport security, public key pinning. So there's a lot of new technologies that allow you to build better and more secure applications. Today, you have the tools to protect yourself against attacks. You have more tools than ever. So 5 years ago, there are a lot of vulnerabilities where there's little you can do against them. Today, you actually have the tools to protect yourself. The real key here is to know what they do and how to use them. A few things, if you're going to build Angular applications, a few things that are very critical and you should consider. First of all, deploy it over HTTPS. Something you deploy today should not be deployed over HTTP. Just don't do it anymore. It's the absolute baseline is HTTPS. Also important, for example, for easy configuration of your Csp policy to be able to use sensitive APIs, because most browsers like Chrome and Firefox, they start blocking access to geolocation if you don't use HTTPS. So there's only advantages, start using it. Authentication, very important. Try to get that right. Try to offer multi-factor authentication, especially with all the data breaches we have today. And of course, if you use session management, for example, and you push that to the client, do it in the right way. Don't don't allow client-side notifications to your session data, and don't make decisions on this untrusted data. Again, a lot of content. I can talk about days on these topics. This is also what I do. I have a web security course. I already talked to a few of you about this course. It's running in December in Leuven. It's 2 days about 4 important areas of web security. So all information is on the website there. If you want to know more about web security in general, I'm going to put, or I have put the slides for this talk online on my website already. There are other slide decks as well, a few recordings, and blog posts about various security topics, including a series on CSP, which might be very relevant for you. And there's a mailing list to subscribe to if you want to stay up to date. And then, if you have feedback about this, you have questions, you want to invite me to another event to talk, my contact information is right there. I'm pretty available, so feel free to contact me with your experience. If you tried out CSP next week and you're like, oh, this is great, tell me, please. If you have a specific scenario that you're saying, okay, this is crap, tell me, I want to know. That brings me to the conclusion. So the rules of Angular security, first of all, do not combine server-side templates with user-supplied data in an Angular environment. That will only cause you pain. So move away from that as fast as possible if you're doing it. Don't mark untrusted data as safe. That's maybe the most important lesson for Angular 1. Don't ever do that. If you're doing that, fix that tonight, before you're having a beer when you get home. And then don't ignore the power of CSP. CSP is really powerful. Use it to your advantage. Use it as a second line of defense. In case things go wrong, you will still be protected by CSP as much as possible. Then, of course, we're computer scientists, so we start with 0. And rule number 0 is tell everybody about this. It's not Fight Club. You don't have to keep it secret. Tell other people. Share this. Share the slides. Tell them about these things, and make sure that as many people as possible know about these things and actually build secure applications. That's what I had for today. I'm still available for questions because my boss leaves in about an hour, so I have plenty of time if you want to discuss topics right now or after the talk. Shoot.
Thank you very much.
Tired and hungry? All right. Thanks for listening.
Thank you very much.